So, Rohit, let's take one last query from Srinivas. You can read it on the chat box. Yeah, the
Okay.
question is, EDA tools are already helping in RC estimation. Are we saying that we invest time, effort, resources in MI to improve upon on the results that current EDA tools give? I'm trying to understand for what kind of problems we should resort to MI.
Hmm. Okay. So I'm trying to understand what kind of problem we resort to MI. Okay. This is $1 million question actually, and I I have asked this question to back in 2012, 13 to many people as to is there any open problem in EDA that machine learning can solve. So people are looking for that. Um, and there are a lot of effort that's going inside the company and academia. I can give you a couple of links to go and find that. Uh, so at this point, the problem is not defined as far as I understand. And I have, as far as I understand, you have to take your shot. And there are two reasons to this. EDA industry as a whole has not come to understand machine learning in a way that what it can or cannot do. So what's happening inside Synopsys and Cadence and a little bit in Mentor is they're experimenting at this point. And based on the customers that I have talked to, for example, one customer in 2017, when I said our product Pacer has machine learning, he just went wild right there. He said, "Oh yeah, we are looking for productivity, and we would like to replace one of our designers. Um, yes, if your software can learn what it is doing." So, so and I was like, I don't know how to answer that. And I said, "Thank you very much," and I got out of there. So, um, pardon my laugh, but it's not impossible, but the kind of resources that project would require, no company will, have that time and effort and resources. It's possible. Machine learning is actually saying that it can do it, but EDA does not have resources to get that done. I can throw a few ideas if you like. So let's say, for example, Virtuoso, right? Virtuoso people use for, number of things, and all they're doing the same steps over and over. So what you can do is use generative adversarial networks, which actually watches an algorithm and interaction with the user, and it looks at how many times this person took this step on what kind of cell and why, and whether it is a good action or not by looking at if that action persisted in the signed off chip or not, right? So you can create millions of those actions, and if those actions were good or not, and create a data set, and then figure out what is good action and what is not good action, and create an advisor within Virtuoso and tell if somebody is doing, let's say, simulation or whatever they do. um, it can act as an advisor that you should do this, um, and that would work pretty good. But if you go and tell this to Anirudh or somebody in Cadence, they're gonna just kick you out. so don't take that chance. But yeah, there are ideas. I mean, I have tons of ideas. But at this point, it's mostly, trial and error as to what is possible within the resources you have. But this idea, because there are these ideas, that's what makes the whole field exciting.
Yeah. All right. Let's continue with these slides.
And Srinivas, somebody said it's a dumb question. I don't know who did, but I mean, no question is a dumb question.
He only
So, Rohit,
said that.
very small question. So the machine learning seems to have a good application in the model extraction. Let's say somebody building a new chip on a given node again and again. So if you change the layout and if you already build good amount of database how the resistance and the capacitance should be extracted, then this machine learning algorithm can definitely be used. How can you reduce your this extraction effort?
I agree. Based on my limited understanding of extraction, actually, so the way extraction works on Maxwell equation, and they run it on certain set to find out R and C's, right? They collect
Right.
the patterns, they create the library, and then they use the library using interpolation and extrapolation to give you RC. So this is the crux of extraction, right? Now, instead of collecting, and that methodology has worked for pretty much every product, extraction product in the industry, 2.5D, 3D. If now you have enough compute power, so what you can do, you can take small blocks and run true extraction on the entire block. And as long as you have all the patterns in the data set, it just becomes, a problem of interpolation or extrapolation.
Yeah.
You don't need the machine learning there. But if you want to push it, you can push it.
All right. I think let's move on. We have 2 more labs to finish.
Yeah. Can I take a break? I'm really tired.
Yeah. Let's take 2-minute break for everyone.
Okay. So just to give you an idea, go through this exercise, understand wire resistance. We are going to move through wire capacitance estimation much faster. We won't have much time. So look at your wire resistance for next 2 minutes.
Yeah, sure. So for everyone, just to make sure you run the lab stepwise, so that you cover all the steps, because that forms the base for the next capacitance estimation problem statement. So I will copy paste the lab again, if anyone missed it. So this is the lab, and you can just click on all the play button and to find out by yourself if it's working fine or not.